All right, we're going to prove by the principle of mathematical induction that 8 divides 9 to the n minus 1 for all natural numbers n. Okay, so let's go ahead and start this proof by PMI. So we're going to do the base case first. So we're going to consider s of 1, right? So we basically need to check if the statement revolving around 1 is true. So does 8 divide 9 to the 1 minus 1? Well, this is the same thing as saying that 8 divides, so 9 to the 1 is 9, minus 1 is 8. And of course, 8 divides itself, right? So that checks. Consider s of 2, right? So is it true that 8 divides 9 squared minus 1? Well, 9 squared is 81. 81 minus 1 is 80. And surely 8 divides 80. So that's also true. So let's go ahead and move on to the induction step. Okay. So in the induction step, we're going to suppose the statement revolving around some natural number k is true, right? For some k contained in the natural numbers, right? Okay, so this implies that 8 divides 9 to the k minus 1. Now remember, with the principle of mathematical induction, we assume that the statement involving some arbitrary natural number k is true, and from there, if we can imply that it's true for some natural number k plus 1, the next term in the sequence, then it would be true for any natural number n, right? So let's go ahead and consider 9 to the k plus 1 minus 1, right? Well, 9 to the k plus 1 minus 1 is the same thing as 9 times 9 to the k minus 1, right? That's using the rules of exponents. Okay? Well, this is saying that we have 9 to the k's, and then we subtract 1, right? So we know this is the same thing as 8 times 9 to the k plus 9 to the k minus 1, right? Because we still have 9 to the k's, we just rewrote it in this fashion. And I'll show you why we did that. Well, of course, 8 divides 8 times 9 to the k, right? Because 8 is a multiple in there, so of course 8 divides it. And we assumed that 8 divides 9 to the k minus 1, right? So if 8 divides 8 times 9 to the k, and 8 divides 9 to the k minus 1, then surely 8 divides the sum of these, right? So 8 divides 8 times 9 to the k plus 9 to the k minus 1. But we do know that 8 times 9 to the k plus 9 to the k minus 1 is the same thing as 9 to the k plus 1 minus 1, right? So what this tells us is we proved that assuming that 8 divides 9 to the k minus 1, we're able to get 8 divides 9 to the k plus 1 minus 1, right? So this means that s of k plus 1, the statement involving k plus 1, is true, right? Therefore, by the principle of mathematical induction, we know that for every n contained in the natural numbers, s of n is true. The statement revolving around any natural number n is true. So we essentially prove that for any natural number, 8 divides 9 to the n minus 1. And that is our proof.